All right, so in this video, we're going to take a look at just combining a bunch of different reflections and compressions, translations, everything we've kind of done up to this point. Right, we were just going to put it all together, right? So let's take a look at our function f of x, right? Again, some function, whatever it may be. In this case, let's just take a look at our absolute value, right? Think of that as our parent function. And let's take a look at, well, I'm going to take that and what would something like this do, right? So let's say our new function g of x is this function here. All right, well, I know what each of these individual things does, and well, here we're just combining them, right? The negative is a reflection, right? It changes all the range values, reflection across the x-axis. The minus 3 here, all right? So here we have reflection about the x-axis. We have a shift to the right. That minus 3 is a shift to the right 3 units. Excuse me. Shift to the right 3 units. And then we also have a vertical shift of 2 units. Vertical shift. Excuse my writing here. Let's see. We have a vertical shift of 2 units up. All right. So even before I get to trying to input in the graph, I already know what this should look like. Right? I know. Oops. Oh. Okay. All right. Sorry about that. So here we go. So now let's take a look at f of x here. Let's switch it up here. All right. And we had our new function g of x. We said was equal to negative f of x minus 3. Okay, so we see there again relative to my parent function here over 3 units. Right, and that reflection across the x-axis, and then finally plus 2 takes that whole function and it shifts it up 2 units. All right, so we can see that we can take these in different combinations. All right, and now that we know what each individual one does, we know when we put them all together what that's going to do to our function. Right, so as long as we know what our parent function, what our f of x looks like, we can incorporate all these different translations, right, reflections and stretches and compressions if we wanted to. All right, so here, for instance, let's see. Let's try another one here. Okay, so let's say we have our f of x, all right, and my g of x. All right, that's going to be 2 times f of x, and then minus 3. All right. So in this case, there's no reflections, but that 2 is going to correspond, since it's outside the f of x, it's going to be a vertical stretch of 2 units, and then minus 3 will drop it down a vertical shift of 3 units down. All right, so here we have a vertical stretch by a factor of 2. And then we have a vertical downward shift of 3 units. All right. And here, plugging this in, all right, so g of x, let's see. So we got 2, and what's it again? Minus 3. So 2f of x, and right there we could see the stretch, and then minus 3. All right. Okay then, and there we have the different translations that go into effect. Okay, so here what we should be able to do now given this equation, we should be able to describe the behavior of the graph, again, relative to f of x, right? If we're just given this g of x function, we should be able to say relative to f of x what the effect of each of these translations would do to the graph.